over here, and okay, so we're given this truth table and we have to use the K-map to simplify this function. Okay, so how do we do this? So first of all, we need to make like a table for the K-map. So for this one, since it's a two variable function, so we have x and y, so we're going to put the first variable over here and the second one over here, and we only have two variables like 0 and 1. Okay, so 0 and 1 goes over here and 0 and 1 goes over here. Okay, so this is how you're gonna set up your table for the K-map. Can make it look like this. Okay, now to set up your function, the f. So this is x, this is y, and these values you see. So for the first value, let me explain. Okay, so for the first value you have 0, 0, and 1. So this is gonna be like 0, 0, and then you're gonna put 1 over here. Okay, so I hope you guys understood. So let's go ahead and put the next one. So you have 0, 1. So this is like this x value is equals to 0, y value is equals to 1, and then the function equals to 1, right? So we have x value equals to 0 over here, y value 0 over, y value was 1, so y value 1 over here. So this is 0 and 1, so we're going to put 1 over here. Okay, so we have 1 and 0, so this is 1 and 0 for the y, so we're going to put 1 over here. Okay, and 1 and 1 for x and y, so x we have 1 over here, and y we have 1 over here, so 1 and 1, so we're going to put 1 over here. Okay, so I hope it makes sense. Let's actually fill the table. So 0, 0, 1, so 0, 0, 1 goes here, 0, 1, 0, 1, that's 1 over here, so 1, 0, 1, 0, that's a 0 over here, and then 1, 1, 1. So that's how you're gonna fill the table. Okay, now once you have filled the table, so you need it's gonna be given in the question whether you want to do product of sum, sorry, sum of product, okay, sum of product or product of sum. If they're asking you to find product of sum, so product of sum means like you have product in the middle and then you have like sum. Okay, so you're summing and then the product. So if it's like product, then the product has to be in the middle. Okay, and but if it's like sum of product, so the sum has to be in the middle, and then you are adding the variables. Okay, so this is how it's gonna look like. And for sum of product, you're gonna look at the ones in the table, but for the product of sum, you're gonna look at zeros in the table. Okay, so you're gonna look at the zeros in the table, and then you're gonna write it in the form of product of sum the same way, but at the end you're gonna apply the De Morgan's law, like you're gonna negate it, and then it's gonna, your final result will end up looking like this, because when you apply De Morgan's law over here, right? So for example, if you have like x, y, and you have like plus xy, right? And if you apply De Morgan's law on the whole thing, so what do you get? Like xy, so it's like ANDing, right? You're ANDing them, x and y, so it's, so the inverse of AND, that's OR, right? So you're gonna end up ORing them, and it's gonna be inverse, inverse, and then this is plus, that means OR, so that's gonna become an and then so that's how it's gonna look like. Okay, so just so you guys understand, so let's go ahead and do product of sum of product over here. Okay, so we're looking at all the 1 values over here. Okay, so we have 1 over here, over here, over here, and for this we need to make the groupings, and groupings are only possible like 2, 4, 6, 8, so all to the power of 2. Okay, to the power of n. Okay, so and you need to do like as many groupings as you can, okay, to cover like all the space. Okay, so here we can do the grouping of this 2, but you cannot like do alone this one, because you can group this with this one, right? So let's go ahead and group this one with this one. Okay, so we have these 2 groupings over here. Let's use another color for this one, so we can use like a green color for this one. It's not too visible. Okay, So this is my group 1, this is my group 2. Okay, so for number 1, so for group 1, what am I doing? Group number 1, I have what? Now let's go ahead and write the function for it. Okay, so that's our whole purpose, because we want to simplify it, so we want to write it in terms of a function. Okay, so we have 0 for the x, and for the y we have 0. So okay, so that means like x naught and y naught, right? X naught, y naught. I hope you guys understood, because it's a 0, right? So that means it's x naught. If it's a 1, that means it's x itself, right? So that's why x 0, x naught, y naught. And then here we have what? We have x naught and then y, right? X naught and y. And since you're doing sum of product, so yeah, you need to put a sum here, and then these are product, right? Okay, now for the group 2. So for group number 2, what do we have? For group number 2, we have 0 and 1. So that's what? Not x and y, right? And then we have what? 1 and 1. So that's simply x, y. And afterwards, you cannot just leave it like this. You need to simplify it further. So you guys need to look if there's something you can factor out. So what you can factor out, the common thing in here. So the common thing in here that I see in both of them is x prime, right? Yeah. So it's x prime in both, because you have x prime in here and in here as well. Okay, and in here, what do you guys see as a common thing? So I see y, right? Now y. So the function that you have to write as a final answer would be the sum of product of these two guys. Okay, so the final answer would be like x naught plus y, and this is the final answer for the key map. Let's do another problem with the 3 variables. Alright guys, so we have this question over here which says, given the truth table, we need to simplify the function, of course, as a key map and as product of sums. Okay, so you guys see product of sum, which means we have to like have something like this, product in the middle, and then